Okay, this is episode 3, and in this episode our task is to get the OLED display going, and to have something to display on there we will get the real-time clock chip here programmed and getting the time so we can display the date and time on the display. And if you don't have one of these little starter boards, then I will show how to do this on a different controller with just a little OLED display attached to it. This little board that comes with the Xiao starter kit, there's nothing magic about it. It's just a convenient way to do our experiments because we don't have to plug in a display. It has a little switch there that we can use, a real-time clock chip, and of course it allows for a battery to be hooked up to it, so it all makes it convenient, that's all. So what the code does, I've already got it loaded in there, and if I switch it on you'll see it happening, is it goes through Wi-Fi to an NTP server to find out what the current time and date is, and once it has that determined then it'll start to display it. I've hooked up one of these little antennas to it, but the actual little antenna that comes with it, which is like a stick-on thing, so if you got this in a little case and you can actually stick that in the case, and I've done that for my keypad that I did a video on, so that would work as well, but it's more convenient for me to use that little antenna right now. So if I switch it on, it is going through Wi-Fi in order to find, there it is, it found the date and the time, and then of course it doesn't need Wi-Fi anymore, so it only temporarily reads that over the internet, and it displays the time and date. And if I push this little button here, right now it's on AM/PM mode, I push the button, it goes to 24-hour mode, or military time as Americans might like to call it. It's 1828 hours and 36 seconds, and also known as 6:23 p.m. Okay, so let's have a look at the code. So I've got this running in platform IO, but it would work exactly the same in the Arduino IDE, and we will have a look at that as well for those of you that are not into platform IO. But in platform IO we have the platform IO ini file, and as you can see we have, well, we're using an ESP32C3 right now, and we've got some libraries here. Holy Kraus U8G2, and we have an ESP32 time from FBIEGO or whatever it is. So they've got some convenient functions there to display and read the time from the real-time clock chip and so on, formatted. And this is the Holy Kraus one, is for the OLED display. And if we look at the source, the main program over here is at the top, so it includes that library, and it includes time.h, and this is some stuff that came from the UG82 software. It determines, it's a generic library, so it works with many OLED displays, and some uses SPI and some uses the I2C, which is the wire one. So it determines, you know, which interface to use. We then tell it which the display type includes PCF8563H. Now, as you can see, I have a CPP file. Sometimes what I do is, instead of including the library in the platform.io ini file, I will go to the GitHub site and I'll grab the code, the CPP file, and over here in the include folder there is the actual header file. Why would you do that? Well, especially if you're using the Arduino IDE, when somebody publishes a library there and they update it, it always says, oh, libraries need to be updated. And then when you update it, sometimes your code stops working because they've made changes to it that actually breaks your code. And then you'd have to go and change your code. If you want to avoid that, if the library you've got works perfectly, that's what you can do. You can go to the GitHub and grab the H and the CPP file and just include them like that. You put the header file in the include and you put the CPP file in the source directory, and then it will find them. When you say PCF 8563H, it'll find it because it's in the include folder. So that's what I've done for that one. And the PCF 8563 is actually what the real-time clock chip is. So that is the code that is used to actually talk to the chip, to program it and to get information from it. So we also include Wi-Fi because we want to be able to get the time from an NTP server, and we are going to be using NTP server pool.ntp.org, which is a generic sort of server that you can query on the internet to get the correct time and date. And in order to get onto the Wi-Fi, I've got a temporary SSID and a password here. Obviously, these are temporary things that I will remove after I finish this video. So these are not my prime SSIDs and so on, but this is working for our test over here. And then we have a structure to actually store the time info, and we have a structure for the time display, which is going to be the date, and we've got 12-hour time and 24-hour time in that structure, and that makes it convenient to display it. And we will create a variable using that structure called TD. In your setup, we're using that little button to switch from 12 to 24-hour time mode. So the button pin, which happens to be D1 for that Xiao starter kit board, that little button that's on there. So we are just saying input with a pull-up. The OLED this screen, this is that code that is related to that library, of course, that one OLED library. And so we tell it to begin, enable UTF-8 print, so that we can use the print function. We set a font, set the font direction. You can set the direction in any four, of course, up, down, sideways, back to front, whatever. We clear the buffer. Then we do a wire begin, and to get the Wi-Fi going, SSID, password. While the status is not connected, we just keep looping around until we are connected. If it takes more than 30 seconds, then, or 30 times half a second, then we will time out and say Wi-Fi timeout, and that's it. We don't go any further. But it always works, at least so far. Then we configure the time, and we have a offset of -7 hours. We are in mountain time over here in the United States, which is an hour later than Pacific time, like California. And daylight offset is going to be 1 hour. and the NTP server that we defined above there, that NT pool. So then we get the local time. If we can't get it, something wrong, then we say time failure, and again we will stop. Then we don't need Wi-Fi anymore, so we disconnect it and we turn it off. Otherwise we'd be wasting power. And then we're talking to the real-time clock chip over here. We set the year, the month, the day, the hour, the minute, and the second. And we start the clock. And then we have a little function here to return the display time. And we use sprintf in order to format it. The time and a date. So we have 02D that tells it to use leading zeros and 2 digits, and so on. And then in the loop over here, if the little button is down on the board, then we switch the AM PM time to switch back and forth to not AM PM time. And actually this bit of code here should be undented. Okay, that'll make more sense this way. So we get the time from the real-time clock. We get the display time. That's, so it's formatted. Then we clear the buffer on the OLED display. We set the cursor. We will print the date. Then we set the cursor to the next line. Then if the time is AM PM, then we print the 12-hour time, otherwise the 24-hour time. Then we send it to the OLED display and we wait a second and go around and do it again. So that is the code. It's relatively simple, but you can see from this how to enable the libraries and things like that. Now, when it comes to libraries, when you go to the Platform.io homepage, you'll see there's libraries there, and the ones that we have included, for instance, UG8, I think, was the, let's bring it up. Now, let me see, what is it called again? It is, oh, UHG2. Back to front. UHG2. So there it is there. And there is a bunch of them. There's an Adafruit one that has extensions to it and so on. But this is the one that we're using, UHG2. And you would just go there. If you're creating and you say add the project, and when you click on that, it says, okay, what project? And you would select your project from the list here that you want to add it to. Now, if you are in the Arduino IDE, like so, you get rid of that. It's a similar thing. You go to libraries. I think that's what it was called, wasn't it? And yeah, there it is, UHG2 by Oliver. And you would say, I've already got it loaded, so that's why it says remove. And you would just do an install. Similar process. For some reason it always has a problem with something, but it works okay. Which actually brings us to the next one. Let's close the And let's go back to the over here. So this one was working. You can turn that off. Now let's bring in this little breadboard over here. This here is my, I think we can do it a bit less light there. All right, this is the M5 stamp C3, and as I've explained in the earlier episode, I actually soldered on some of those sockets, which are the same as what you will find on this board here, Grove sockets. And I have actually hooked up a little OLED display to it, and it's just counting up. It's been running for 27 minutes by the looks of it. And the interesting thing is that they have wired those pins on this particular device in the exact order that you would need for one of these Grove sockets. But let me switch it off. If I display unhook this little display over here actually has pins on it. That's how it comes. And if I plug that into here by itself into the breadboard, it will do exactly the same thing. There we go. Now it's back to zero, of course. So that's another way to deal with it. I made up this little cable for other devices that you can actually plug it into one of those Grove sockets. These plugs, you'll find them on AliExpress. A HY 2.0 is what they are, 4-pin. And I put some little DuPont, female DuPont sockets on there, so you can plug it into those little header pins. Now this thing here is just to show that you can use any little OLED display. You don't necessarily, to follow this series, you don't necessarily have to have that starter kit. It just makes it easier, but this works as well. Now these little OLED displays, you will find them, they are dirt cheap. You'll find them on AliExpress for $1.83. You can get them in white, blue, yellow, and I don't know what's the difference here. Seems to be the same. Then that one surely. For some reason suddenly it's $6. I do not know what the difference is. Oh, I see, that's 5 pieces. That's what it is. You get 5 pieces for $7. Okay. Anyway, there is no information whatsoever on this website, but you can see that it is 128 times 32, and when you go to the code, this is actually comes from the when you go to File, Examples, the UG2, and yeah, Hello World. That's where this came from. I've renamed it to Hello World OLED. And as you can see, it supports all these different boards here, and I just used I looked at the ones that says 128 times 32, and I know that it only has an SCL and an SDA pin and no reset pin, so I selected one above that didn't work, and then I got to this one, and this one started working. So that's the one to use for that little board. And because it's the stamp C3, the clock is on pin 1 and the data is on pin 0, and it doesn't have a reset pin. So, and that worked. And I just put some test code in there. I've got just some stuff here set up. U8x8 begin, set power save to 0. This came with it. I didn't write this code. This was already there. I created a few little things here: get hours, get minutes, and I set a counter to 0, and once a second I incremented. I could have used the millis function there to get how many milliseconds this control has been running and get it from there, but I decided to do it in a simple way. And this code was mostly already there: set font, drawstring, and I changed it from hello world to hello OLED. And it has character array with 16 characters, and it says get hours and increment the count, and there will be a remainder because what we're doing is we are returning the modulus of the 3600, which is an hour in seconds, and then the minutes. I then give the remainder as input to I, and then there'll be another remainder which will be actually seconds. So I then format that, and actually I could put 0 2 there, couldn't I? Like so. Some leading zeros on there. And I draw the actual string on the screen. Originally I was drawing a string of this stuff, but it's actually too wide for the display, and it put it in inverse font, but I didn't want to use that. Then I just refresh, and that's it. So let me see now if I plug it in to the USB port. It'd be on COM8, I believe, yeah. So if I say upload, all right. So there we are. Hello OLED. And when it gets to 59, it goes to 60, it'll be 1 minute. So that's it. We have code now to access our OLED display. So for the next episodes, when we're going to try some of the other sensors and do some other projects, we can display stuff on there, so without having to use the serial monitor, which will be kind of neat. Okay, so that's really it for this particular episode. Don't forget to like and subscribe, and to be notified, that little bell thing or whatever, so that you'll know when there are some new episodes coming in this series. And I'll see you guys later.